All right, so playing around with the lighting a little bit here. So let's continue exploring limits. The last couple of ones we did, we were able to find the limit by plugging in. Here, we're solving the problem limit as x approaches 3 of x squared minus 9 over 6 minus 2x. If all that I know to do is plug in, we're going to get 3 squared minus 9 over 6 minus 2 times 3. The numerator is equal to 0. The denominator is equal to 0. Usually as a class, this is where we say, uh-oh, it's the indeterminate form. I-N-D-E-T-E-R-M-I-N-A-T-E, indeterminate form. What the indeterminate form 0 over 0 tells me to do is we need to try some algebraic manipulation. So we're going to go back over to our original expression, x squared minus 9 divided by 6 minus 2x, and we're going to look for algebraic trickery that we can do. And so here's what I'm going to do. I'm going to be careful to write the limit. It's limit as x approaches 3 still. If I'm thinking like an algebra student, I see this x squared minus 9, I recognize it as the difference of squares. That might be helpful. There I have x minus 3 times x plus 3. In the denominator, I have 6 minus 2x. I can factor out a 2, leaving me 3 minus x. And this is where you want to be careful. I have an x minus 3 in the numerator. I have 3 minus x in the denominator. They are close. They are not identical expressions that are just going to cancel out and make fancy 1. X minus 3 and 3 minus x are opposites. And when you cancel out opposites, the result is you wind up multiplying by negative 1. We get the limit as x approaches 3 of the negative of x plus 3 over 2. Now let's try plugging in. We get negative 3 plus 3 over 2. 3 plus 3 is 6. Make it negative. Divide by 2. Negative 3. So my conclusion would be that the limit as x approaches 3 of x squared minus 9 over 6 minus 2x is equal to negative 3. Done. We're happy. Move on. Let's try a harder one. A new trick that many of you were exposed to this year is going to come up in this next one. But let's approach this with fresh eyes. I need to find the limit as x approaches 4 of the square root of x minus 2 over x minus 4. Let's try plugging in. If I do that, we get the square root of 4 minus 2 over 4 minus 4. Square root of 4 is 2. 2 minus 2 is 0. Denominator 4 minus 4 is 0. Uh-oh, indeterminate form. Let's try some algebra. We come back to the original expression. And for me, I'm keying in on the square root here. The fact that I have a square root in the numerator is the hint. And what we're going to do is we're going to multiply by the conjugate of the square root of x minus 2. The conjugate of the square root of x minus 2 is the square root of x plus 2. To form the conjugate, you simply change the sign in the middle. If it was negative before, now it becomes positive. But I need to be careful. When you multiply we're multiplying this fraction by the conjugate, we're going to really multiply the numerator by the square root of x plus 2 and the denominator by the square root of x plus 2. Let's see why that's so helpful. In the numerator, I need to multiply these two expressions together. Algebra students at Yes Prep typically make a box. One factor is the square root of x minus 2. The other one is the square root of x plus 2. We find the area for each shape. The square root of x times the square root of x is x. X square root of x times negative 2 is negative 2 square roots of x. Positive 2 times the square root of x is positive 2 square roots of x. Positive 2 times negative 2 is negative 4. When I add these four terms together, the negative 2 square roots of x and the positive 2 square roots of x will cancel out, which gives me, in the numerator, I now have the limit as x approaches 4, The numerator is x minus 4. In the denominator, I could multiply my denominators together using the box, but for right now, let's just write out the denominator as it is. And if you see this, we have the limit as x approaches 4, x minus 4 over x minus 4 times the square root of x plus 2. Those now will cancel out the 2x minus 4's. And so we have the limit as x approaches 4, 1 over the square root of x plus 2. We can now plug in. We have 1 over the square root of 4 plus 2. Square root of 4 is 2, plus 2 is 4. We get 1/4 as our final answer. I want to use good notation for everyone that's out there. So we get to say that the limit as x approaches 4 of the square root of x minus 2 over x minus 4 is equal to 1/4. Done. One more algebra trick that I want to walk us through. We're going to find the limit as h approaches 0, 1 over x plus h minus 1 over x all over h. If we try the plugging in method again, it's h that's approaching 0. Nothing is happening to x. H is approaching 0. So we would have 1 over x plus 0. X plus 0 is going to be x minus 1 over x. The denominator gets closer to 0. Uh-oh, indeterminate form strikes again. 0 over 0. Let's go back and look at this expression. I have a fraction minus a fraction, all being divided by h. The algebra trick here is we're going to try, maybe this will help, maybe it won't. I know that it will, I built the problem, is we're going to find a common denominator for these two, and let's go through and do that. So I need to find the limit as h approaches 0. We're going to focus just on the numerator. 1 over x plus h minus 1 over x. For me to build a common denominator, I need the x plus h in there as a factor. I need the x in there as a factor. So the common denominator is going to be x times x plus h. So I multiply this guy over here by x. I can't just multiply the denominator by x. I multiply the numerator by x as well. In the second fraction, to build the common denominator, I needed to multiply the denominator by x plus h, so we're going to multiply the numerator by x plus h as well. This whole expression is still over h. Let's keep going. We find the limit as h approaches 0. This first fraction, fraction times a fraction, we multiply the numerators to get x. In the denominator, we have x times x plus h. Minus, we move on to the second fraction. 1 times x plus h is x plus h. The denominator, we have x, and we have x plus h. All that still is going to be divided by h. Still focusing on the numerator of the big fraction. This is why we're doing all the work. We now have two fractions. They have the same denominators. In order to subtract them, we're going to subtract the numerators. We have the limit as h approaches 0, x minus x plus h. All of that divided by x times x plus h, and then divide by h. X minus x, those x's are going to cancel out. We then have the limit as h approaches 0, negative h over x times x plus h, all being divided by h. I have one big fraction up here. I have h in the denominator. Most of the kids at East End have learned keep it, change it, flip it. What that means is, in order for us to divide fractions, we keep the top fraction as it is, negative h over x, x plus h. We change this division bar to multiplication. We flip the denominator. H flips to become 1 over h. The fancy word, we found the reciprocal. Now I'm multiplying fractions, numerator and numerator, denominator and denominator. We get the limit as h approaches 0, negative h over x times x plus h times h. I have an h in the numerator and h in the denominator. We get the limit as h approaches 0, negative 1 over x times x plus h. Oh my goodness, this is the longest problem we've ever done. Hold on, we're almost there. Now let's take the limit as h approaches 0. Let's plug in the 0. We get negative 1 over x times x plus 0, which is negative 1 over x times x. That is negative 1 over x squared. This right here, my friends, is the final answer. So you might say, that's the answer? What the heck was the question? I don't remember anymore. It's all the way back over here. The limit as h approaches 0 of 1 divided by x plus h minus 1 divided by x, the whole thing over h. That limit is equal to negative 1 over x squared. Done.